This video is about the diode and two specific types of it. It is presented by Santiago Hernandez and Sara Murti. A diode is a semiconductor device that essentially acts as one-way switch for current. It allows current to flow in the one direction, but does not allow current to flow in the opposite direction. Diodes have a polarity determined by anode positive terminal and cathode negative terminal. Most diodes allow current to flow only when voltage is applied to the positive anode. Diodes are also known as rectifier because the chain alternate current is IC to the pulsing directing current DC. Diodes are classified according to their type, voltage, and current capacity.
Generally, what characterizes a diode is the p-n junction. This divides a single crystal of pure silicon into two zones, whose border is defined by a flat. One zone is doped with p-type impurities and the other in an n-type. The p-zone has excesses of holes and obtained by introducing group 3 atoms in the crystal lattice, for example, boron. The end zone has electrons in excess coming from atoms of the group 5, phosphor.
There are different types of diodes that are classified by their potential barrier or material. The two types that we select are the tunnel diode and the Schottky diode.
The Schottky diode is characterized by a smaller semiconductor metal ejection doped and his name suggests it also produces a rectifying effect if the doping is very strong in the union is the amic type and the current flows in both directions. Just like in the ejection diode, a depletion zone is formed in which electrons form and sun seek lower energy levels and deposit into the metal. When the area of depletion this passage of electrons from the metal to the semiconductor forced by the field current, which equals the previous one, and therefore no current flows through the device. In the Schottky diode, the potential variety is lower than in an injection diode. It's only two um, when injection when the ejection diode is forward placed, holds an injector from the p-type semiconductor into the n-type semiconductor and electrons from the n-type semiconductor into the p-type. These charges are momentarily stored in neutral zones near the ejection until they recombine with the opposite charge. However, when the Schottky diode um, formed by forward-based, the height of barrier of semiconductor electrons is decreased and the electrons in the in-zone pass to the metal. This result is that in the Schottky diode the conduction is carried out only by the electrons, and for this reason it is also said in the unipolar device which conducts because majority. This also translates in the reverse recovery time will be exponentially forward, very small, and there are no shares stored when the diode is cut off.
Based on what was mentioned above, the behavior curves is as follows next to if you can see the diagrams of type of diet. Applicants. This low forward voltage drop is extremely useful when the Schottky diode is inserted with a power source, sources such as in reverse voltage protection circuits as it reduces power losses. Shocky diodes can be used to temperature regular circuits against accident applications of reverse polarity at the input. Direct D1 serves that purpose in the example. The main advantage of the direct is the application is its low forward voltage drop. A more important function for a Schottky diode in the case D2 is to provide a return path for the current through the input L1. When the switch is turned off, the two has to be fast direct connected with a short load inductance lead to perform this function. Shocky diodes provide the best performance in this application for low voltage supplies.
In the tunnel diode, Saki diode, in a in a heavily doped P injection diode, and tunnel or Cernet effect may occur under reverse bias conditions. If that both semiconductor regions are very strongly doped, on the order of the 1000 times more than in a standard diode, the depletion zone is very narrow and the file in the depletion zone is so great that the tunnel level of Xenoraxo becomes important for the cause of forward bias. Under these conditions, the current voltage of the diodes changes drastically, observing a region in which the current decreases with increasing forward bias voltage. As the forward bias increase, the current increase very rapidly from zero to peak value of ID at which the break occurs. Then the current falls to a volley current, giving rise to the region of negative resistance. A said region is developed characteristically in the range of the uh, 50 to the 250 voltage from the valley voltage. The tunnel diode behaves practically like the normal diode. The reverse breakdown voltage does not exist, though therefore of the tunnel diode is not able to block reverse voltage like other diodes.
And the viral curve is observed in the site. Applicates a tunnel diode is a type of diode that is capable of very fast and the micro-frequency range. It is the quantum mechanical effect that is known as tunneling. It is ideal for fast oscillators and reserved to its oscillators negative sloped characteristics, but it cannot be used in large integrated circuits, so its applications are limited. The circuit you see in the image is from an auxiliary circuit. Tunnel diodes can be used as high-frequency oscillators as the transition between highest electrical conductivity is very fast. They can be used to decrease oscillator as high as 5 Hz. They are even capable of creating an oscillator of 100 Hz. It's an oscillator digital circuit. Thank you so much and reference.